All right, good morning, good afternoon, good evening. Welcome to this message format virtual open house event. My name is Ilungo Charan, and I'll be the moderator for today's event. As a reminder, this session is being recorded and will be posted to the Unicode Consortium YouTube channel. Please raise your hand using the Zoom hand raise feature to ask a question during the Q&A. And you can also use the chat box for questions. But keep your camera on during the session if you can. But if you're shy, we understand. We'll spend the first 20 minutes of the hour hearing from Addison, and then after that, we'll have 40 minutes for the live Q&A. All right, let me introduce you to our virtual open house team. Addison is the chair of the message format working group, which is a part of CLDR. Karen Dawson is the community engagement and events manager at Unicode. And I am a contributor to message format working group and the vice chair of the community engagement team at Unicode. So let's get started.
All right. Just a little bit of fun here getting the slides in place. So, hello everyone. I'm Addison Phillips. I am the chair of the message format working group. Is that not sharing? It's not shared. Okay. Can you see the screen, Alongo?
Yep, looks good.
All right. Now we're in all in one place. So, I'm the chair of the message format working group at Unicode. It's a working group of the CLDR technical committee. And I'm going to talk today about our work on message format 2. We work in GitHub. If you're interested, here's a link to our GitHub repo. You don't have to remember this. We'll have this in the comments on the YouTube later and on other places. But this is where we do our work. We're seeking feedback in our GitHub repo under issues. You're welcome to file issues against our spec and so on. Let me talk a little bit about message format, why message format is interesting, and why a new message format is even more interesting to us. If you work at all in the realm of software, in internationalization or localization, you probably are familiar with messages that need to get created, that your user interface designers want you to create, in which you need to insert some data into a string, or in which the string needs to be different depending on the value of some piece of data. So here's a fake dialog box, maybe from some game application. And you can see in red, I've highlighted different places where you might want to have inserted some data into a string at runtime based on, based on whatever the user interface requirements happen to be. And you could do that by coding individual little pieces of string and making and formatting individual values. But a much better solution to that is to have a message and then at runtime have a piece of software insert and format the value for you. So message format 1 provided was built into Java, is built into ICU4J, and has been ported to a number of different platforms and frameworks over the years. And it looks sort of like this for the middle message that you see here, where you have a curly bracketed thing with a name or sometimes a numbered variable, and then some instructions for how you would like the value to be formatted. And this is super interesting if you're a software developer, because if you have a message like that, then you have a simple code pattern, which is shown in kind of in the bottom, in this bottom box you see here. And you'll notice that none of the logic for how the numbers should be displayed or any of that sort of thing is in the code. It's all inside of the message formatter and inside the pattern string that you supply to the formatter. And so if you look at this string, one of the problems with it is If you insert the number 1 and you say you have won 1 games, that's probably not grammatically correct. And so you need a little bit more structure there. And so we could use, for example, in message format 1, a plural formatter, and it might look something like this. The code didn't change any, but the message still is able to select a grammatically correct string. And of course, because we're putting 2 numbers in, we actually have to do that twice. And here we begin to see where message format 1 is kind of challenging. So here is that message as message format 1. And the formatting you see here has been added to make the message more legible. Actually, most of the spaces and line breaks and so forth are not generally present. So that's one challenge. And then you see that num matches that's in gray. Num matches there has 5 levels of nesting with curly brackets that you have to manage. And you can imagine if I had 3 values being inserted, how complex writing a message like this might become. So that's one of the challenges that message format had delivered to us over the years. A different challenge is that people saw that previous slide and said, I don't need to do that in English. I can write a message that looks like this, where the plural just goes around the parts that change in English. And the challenge with that is it's not a single thought that gets translated. And therefore, in some languages where the words that are highlighted in gray here need to change when you change the words inside the brackets, this is an untranslatable message in message format 1. And so we need ways to ensure that instead of being a super powerful string concatenator, we get complete thought strings to translators, to translator, to translation technology to translate. And message format 1 does not prevent this in any way. Another challenge that message format developed was the original message format, the one you find in the JDK, has 3 kinds of formatters: string number and date time. And 15 or so years ago, ICU added message selection and including plurals and ordinals. However, it did not add, and the syntax doesn't really have an affordance for adding all the other formatters. And so we have way more formatters in ICU, for example, than you can access with message format. Plus, if you write your own code, you can't plug it into message format. So it's not extensible. And this has been kind of a challenge. And as software developers often do, when you have faced with a challenge like that, open source people went out and built lots of different solutions to the problems that I'm kind of outlining here. And so there's a banquet of open source. I call it the food supply. You can choose whatever libraries you want off the banquet of open source table and choose to put that into your software as a software developer. And that's led to sort of a challenge, because then the resource files go to translation land. Translators see all sorts of different formats. Therefore, no toolings have been built up to support message format or any other syntax beyond very, very sort of simplistic kinds of things. When what we'd like to have is a sort of a unified ecosystem where translation and software development can work in tandem to get their jobs done, and there's a consistent format that people share that produces the right effective outcomes, like not a string concatenated thing, but actually grammatically correct target strings for people to translate. So what we'd like is for message format to be in what I call the water supply. We'd like it to be built into frameworks, programming languages, and runtimes, generally speaking, everywhere, as many different places as we can. We've designed message format to be portable between many different resource formats and many different runtime formats, with the hope that we can get broad adoption and help spur things that way. And eventually, being the air supply, we expect developers will expect that messages get formatted using the syntax, and so they'll become used to it. They'll become used to writing messages like this. So, what is message format 2? We built it in out of several pieces. The first is we have a syntax, and the focus of message format 2 is actually the message syntax. And we have a formal grammar for that using the ABNF grammar. We also have specifications that talk about how the syntax works, talks about how to do formatting from that syntax, and then a data model which is exchangeable between different implementations. On top of that, we have a function registry, and we'll talk about that in a little bit, and some test suites for checking compliance. We'll start with the syntax. As I mentioned, we have a formal grammar for message format. One of the things about our grammar that's maybe interesting, maybe even be surprising, is we've worked hard to make the syntax embeddable. So, for example, we don't define any Unicode escapes. We don't define any character escapes. We don't use ASCII quote marks. The reason for this is because all of your message format 2 messages are likely to be written in some other resource format. So a .properties file, for example, or a Java list resource bundle, or a get text PO file, or whatever your format happens to be for storing these. Every one of those has escape syntaxes and character escapes and so on. So if we define stuff like that, then our escapes would be interfering with those or be double escaped, and that's a kind of an icky place to be. So we have a very, very clean syntax, and we expect that the container will provide support for these other things. I mentioned we don't use the ASCII quote marks, the double and single quote in our syntax. We've avoided those because quote marks mean something in so many formats and so many different other syntaxes, and so we use different symbols instead. So what's a message look like? Well, every string is a message format string. So hello world is a message format string. It's not a very interesting message format string because there's nothing to format. But interesting ones we could call a pattern. A pattern has something to replace in it. The thing that gets replaced we call a placeholder. Placeholders in message format 2 look like placeholders in message format 1. They're delimited with curly brackets. And then they have the name of the thing inside that's going to be formatted. In our case, we've added a $sign to the front of the variable name so that it's distinct from other tokens that can appear inside of a placeholder. A placeholder can be annotated. The most common annotation is to add the function that you'd like to use to format it. So in this case, we have the variable $time, and we want to be sure that the time function is used to format that, and the function is denoted by a colon in front of its name. Functions can have options. The options are defined for different functions. Here's a time function, and it takes maybe a time zone option, and we passed a string with a time zone ID in this case to it, and so now we can have a sort of a complete message which has all of the different pieces in place: an operand, a function, and its options. These are all described by a function registry. There is a default registry that's required by every implementation of message format 2. But we also expect people to build different kinds of registry extensions. One of them is what we're temporarily calling RGI, recommended for general implementation, which are functions that we don't think we can require everyone to implement, but which if you do implement it, you want to implement it this way. In addition, individual frameworks, be it a library like ICU4J or a runtime like the ECMA 402, the JavaScript implementation, they'll implement their own functionality that extends the default registry. And then you can write your own function and plug it in. We hope that you'll be able to plug it into any implementation of MF2. And so you can make your own functionality and add it on and have it work just like the built-in functions in message format 2. We have a registry language that language is machine readable. And the purpose for that would be then your localization tools can then read your registry for your function and decide, for example, how to generate translation options. And we'll talk a little bit more about that later. We have some support for markup in the form of a different flavor of placeholders, opening, closing, or standalone. We don't have an implementation of these or any requirements. This is sort of pretending to be HTML here at the moment, but we have some support for being able to place those, and you can imagine being able to move those around and so forth in the translation process, as opposed to having just, angle brackety stuff in your string, which your tools then have to understand. For the initial release, we have these 6 functions in the default registry: string, number, integer, date, time, date, and time. We'll have some additional functionality in the RGI registry that we're building during the tech preview period. We have a Unicode reserved namespace, and we'll have, and then each implementation can use namespacing to implement its own functions or option extensions to the built-in functions. You may not see all of the different functions that you might hear. A lot of people are interested in things like gender agreement and that sort of thing. Those things are being developed, and they'll probably come up through the RGI process when we get that established and running. This is the minimum set of stuff you need to have compatibility with MF1. This is also deliberately narrow in scope so that many different programming languages can implement this without having to import large blocks of data. So, for example, we don't have a person name formatter here because the data for that is probably a little large for a small language implementation of message format too. So we don't require it, but there will be a pattern for it in RGI for people to use. I've mentioned variables as operands. You can also have literals, strings, basically, that you embed. So here's an example of a string literal with a person's name. Emily is one of the contributors to message format, and so there's his name, and you can format that as a string. You can also have functions that don't have any operand. They could just be straight up. We don't have any in the default registry, but you can imagine such a thing. We provide for that. Literals are denoted by pipe symbols because pipes are relatively rare in text. Some literals can be unquoted because they don't have spaces and they use a limited set of characters. In particular, you can write most numbers as an unquoted literal in our syntax. This can be interesting because, for example, you can pass a literal as a value and have a formatter format it for you at runtime. So here we can pass 5 p.m. and have it format AM, PM in locales that use that, and format as 24-hour time in locales that use that. And the translator doesn't have to change it for every locale. It just gets formatted automatically. So that's kind of cool. So far, we've looked at simple messages that are just a pattern with something to be replaced. It should be unsurprising that there are also complex messages. Let's talk about what goes in there. And the first thing is we have what are called declarations. So if you write a placeholder, you might find yourself writing a bunch of options in it, and that's kind of ugly and unfortunate looking. So you can write a .input statement to decorate a value with a whole bunch of annotation, and then you can just write a simple pattern like this. You last played on date, and all of this annotation gets put into date for you because you've declared it earlier in the .input. You can also do something like declare a local variable that might be used to modify a value that was passed to you, or it might be used to create a value out of thin air by calling a function, for example. In this case, for example, we have a date and we annotate it with date, and then we want to also have a time field because we want to have a sentence where the time and the date are separate in in the string. And so here we annotate date again with a different name, $time. Inputs and local declarations are immutable, so you can't use the same name twice. This is illegal. You need to create a second name to make this, local time one to make the second line potentially valid. So then there's the body of a message. You've already seen patterns. Patterns can be a quoted pattern. We quote patterns with double curly brackets, just so you understand what you see that coming up later. So here's our plural. Again, this is the num matches played string that we saw earlier. Here it is in message format 2 underneath. We have a dot match statement. All of our statements start with dots. And then you have a selector, which is an expression that has the value and its annotation. So in this case, num matches with an integer. By default, numbers use plural rules to do selection. And so we have the three classic ones, 0, 1, and star, to have the three different pattern strings. And these are all quoted with the double curly quotes, as you can see. Spaces in our syntax are optional. Line breaks are optional. I kind of want to remind people here, the sort of attractive display that you see on all my slides is not actually required. And so you can write that same message just like you see here, just all one line with no spaces. You can adjust the spaces as you see fit for the optional space outside of the actual pattern strings. Okay, so each one of these lines in the example is what we call a variant. Each variant has a key or a list of keys, actually, and then the pattern. And there's more than one kind of matcher. I showed you integer. There's also number. There's a string matcher, which works like select format in MF1. So there's an example of that. And then you can have as many selectors as you want in a match statement. So here's an example with 2. Again, this is the one we saw earlier. You've won some number of the number that you've played. And so here are 2 selectors, the num played selector and the num1 selector. And then the key list, the first key corresponds to the first selector. The second key corresponds to the second selector. And we do a best match on the matrix of these different variants to choose which pattern will actually be used to render the message. Now, this is the rules for English. Don't forget that other languages have more complex needs. So here's that same message, perhaps implemented as Polish. And I don't show you all the pattern strings so that I can have a pretty illustration. But all of those different strings have the little bits of grammatical variation required for Polish for cases like if you have one number played and one number won, one number played and a few number one, and so forth and so on down the list. And this is a complete set that would be needed to implement, for example, the Polish set of messages. This explosion can be generated using the registry so that we know what to expect to put in here. And so this can become quite complex, but you can see, unlike message format 1, these are all individual segments that can go to translation land separately. They can be managed effectively. There's no nesting or embedding or anything crazy like that. What's the status? We're coming up on the LDML 45 tech preview. So when LDML 45 ships, we will officially be in tech preview sometime next week. I hope to have CLDR-TC's approval of the preview tech release. We currently have 3 implementations that should be available around the time of the LDML 45 release. JavaScript, ICU4J, and ICU4C. We would like more implementations, please. And yes, you can use this. It should be fairly stable. We will only be really bringing in fairly minimal changes, errors and such. We also very much would like to have feedback on, additional proposals for registry entries to suit additional needs and so on. And we want your feedback. Where did we go wrong? What's, how well is it working for you? We'd love to hear that it's working great for you. But our goal is to be stable, have a final edition, incorporating all of your feedback in the fall of this year. So with that, I will go to our questions in our audience.
Great. We're starting to get some questions coming in, and they're all good questions. So let's go to the live questions first, because you all are here and asking, and then if there's time, we can also pull from some of the questions you've submitted prior to the event. The first one comes from Brian McConnell. Brian, do you want to unmute yourself and ask your question?
Yeah, thank you. Yeah, I was just curious. So I've run localization in a number of companies, and ICU messages have always been kind of the bane of my existence. That's not a criticism of the format at all. It's just that a lot of the developers end up working with it or not. They don't have a lot of experience with localization. And so one of the things I've been wondering is if there's a role for machine translation or AI translation, whatever you want to call it, to kind of pre-translate, these sort of dynamic messages, because it does seem like it deals better with gender and things like that. And my assumption is this is going to continue to improve. So it's just kind of curious about your thoughts on that.
Yeah, I think that's a really interesting area. I had only like 20 minutes here. And so in my long presentation about this, if you watch the UTW presentation, I spent a while talking about like generative AI and that kind of thing. There's a role, there's definitely going to be a role for that in message creation and management. In the group, we call this the bone dragon problem. It's like you have an unlimited set or even a large set of count and gender variant things that you want to stick into the middle of a sentence and then say different verbs and numbers and stuff on it. And the permutations in something like a message format are too large to be reasonably handled. And so that's a challenging space where a generative AI, a large language model, might be a better long-term solution. However, there are plenty of applications that can't run a large language model. They're embedded applications or handheld or whatever, and there are too many languages in the world that don't have good large language models, at least today. So for the foreseeable future, that's not a thing you can do.
My general advice with developers when they start developing kind of complex messages is don't do that.
Don't do that. But at the same time, I remember many years ago, Mark Davis and I were talking, and he says, "Well, we're at Google, we're going to limit everybody to one plural." And I'm like, "Have you met my UX designers? They want 2 plurals in every message, and if they can get 3, they'd be even happier." And so MF2 partly is to help with that problem, which is, among other things, we short circuit developers' desires to write little string concatenation things, we hope, by making them write complete pattern structures, but also setting it up so that machines can generate the permutations for them, setting it up so that tooling could generate things directly. It'd be really fun if there were a Figma plugin that generated MF2 templates for people. So I think there's some stuff there, and I think a lot of people are using MT for their localization process already. And so providing a machine readable registry will help us connect the dots a little bit better, including going, hey, we need to feed back to the source developer. You need to recast your message like this, but there's a really simple selector you throw in here for gender, let's say.
Mhm.
And now you just need to know, if I'm putting a noun in, I need to put the gender selector on it, and away I go. So I don't have to think about it anymore. And I don't have to put it in my code. And that's, for me, as a key thing. I don't have to put it in my code. It's this magic IETN thing.
Cool.
Cool.
Thank you.
Thanks for the question. The next one is about validation data sets or testing. This is from Olivier Stecke. So do you want to unmute yourself and talk about your question?
Yeah, sure. Thanks. Thanks for the presentation. That was more about, the implementation. I guess that I didn't check, but the 3 implementation that you discussed during the talk are open source implementation. And my question is there a plan to have a kind of validation data set, or something that, okay, if you run through all that stuff and you got that message, it means that the implementation is correct, or at least we can be confident about the implementation. That's more.
Yeah, absolutely. And that's a key one of our deliverables. It's we have a certain amount of test data set already, but we're going to continue to build that out. That's one of the things that's going to mature during the tech preview period, because implementers are catching up with a bunch of changes that have come in the syntax and some other things, kind of late breaking. But we, to some extent, have a test set like that today, and we expect to flesh it out fully by the time we exit tech preview, such that you can push a button on your implementation and say, here, we run all these tests, we get all the expected results, and therefore we are compliant with MF2's requirements.
Okay, thank you.
I was just curious, are there things that you're looking for beyond just having this in place? And the reason why I ask is because I'm looking into this. Like Emily has created the initial set of test cases, but we need to look into that and see, does it actually conform to what we're expecting these test cases to actually support? And so I'm looking into that. Matt Radborn, who's also on the call, is looking into that. So if you have any ideas about anything beyond that, any details, we're open to that.
Okay, I'm not the specialist of testing, but I know somebody who is in the room.
Okay. All right. Well, if you have any feedback, you know where to find us.
Okay.
Thank
I
you. The next question is from Eric Fiozna. So Eric, if you're on the call and can unmute yourself, do you want to ask your question?
Yes, hi. Joining from Stockholm. Hi, everyone. I had a very practical hands-on question. We are advocating for adopting message format and ICU4J in general in the company I'm working for. And the one thing is, most people were not aware of the existence of message format, which is quite sad in the first place. So we're doing a bit of education on that side. But once we have good adoption for that, that will be V1 at this stage. So I'm just wondering to which extent there might be an effort required to adopt V2 the moment the technology is more mature. And the main question is basically, is it retro compatible between V2 and V1, or do we need to automate some changes in the source strings files?
The pattern strings are not compatible. The things that we did to the syntax mean that a message format 1 string will fail as a message format 2 pattern, and vice versa. The message format 2 strings won't work in MF1. So that is, from that perspective, they're not the same thing. There already is a mapping, and there is tooling where you can convert a string to MF2's data model or to MF2 itself from MF1. And so that may be a course of migration. There are also message format 1 strings that will require human assistance to move. So if you remember the string I showed you with the badly internationalized plural, that won't translate to MF2 directly because it's not organized in an appropriate way, and you'll have to help it by recasting everything into complete thought sentences. So that's there will be some migration required.
Okay, and you mentioned there is a mapping existing. Is it something that exists in codes in ICU directly, or is it rather
Don't believe
something...
it's in ICU, but there is one. There is a piece of code extant, and I'll look that up and add to the to our set of links when we're done.
Okay.
So
awesome.
Emily has one for I think for JavaScript. So
awesome. Thanks. That was all from me.
Cool.
And Addison, is there anything that you wanted to touch up on, like the trade-offs of the new syntax not being compatible, but also the whether or not it handles quote unquote bad internationalization?
Not sure I quite follow. You can write badly internationalized strings in MF2 also, but it is harder to do because, for example, you can't write a string concatenation directly. You can concatenate strings using literals and stuff, but you can't do like what I showed you in that one slide. One of the reasons the syntax is incompatible is because it's extensible. And so you can actually plug in your own functions to this thing, which you couldn't do before. And to do that, we needed to make functions self-identifying. And and you need to be able to make variables self-identifying. And so that's why it's somewhat different. Yeah, Mark commented he thinks it'll be possible to convert broken MF1 into valid MF2, and that's true. But I think it will be harder for a machine to do it. It won't be, it won't just be drop this string in here and it spits out you can get an MF2 string out of it, but it'll be it may require some intervention.
Oh, I think. Can you hear me?
Yeah.
Yeah. I think it's possible because you can take the fragments and generate all of the possible messages based upon the selects, and then order them in the match and order them in the keys. And I think mechanically we would be able to do it. Now it would be just as broken as the original MF1. So, but produce the results that the MF1 would have.
Depends on how broken your MF1 is. So
yeah. But I think most of the broken MF1, which by the way, a lot of tooling, I know our tooling disallows that because of the problems, and I'm sure other people do the same thing. But I think a lot of those, if not all of them, could be converted.
Every message can be converted. Some message, and it's maybe even possible to make it fully automated.
Yeah, that's what I mean by can be converted, because nobody wants to do this manually.
So, cool.
All right, thank you for the question. The next question is from Bert Bose. Do you want to ask the question, Bert?
Yes, a simple question about the syntax. I noticed that the match statements can be quite long, but you also have a .local, the way to make abbreviations. So I wonder, can you make a local variable hold a whole match statement?
No, and the reason for that is the match statement is so long because it has all the patterns in it, and so match is always at the end, and it's basically an array of patterns, one of which will be the pattern that's going to actually be formatted at runtime. We've debated about whether to allow you to do statements in statements. So, for example, to have a .local that runs its own .match to select, like to do a plural, for example. And we decided against doing that. That'll be something that we maybe would want to talk about more in the tech preview period. But our thinking there is that the most common use for that is message references. You know, if you want to put the name of a button into a variable and then insert that at runtime inside of a larger message, for example. That the way to do that is to have a separate resource and to have at the resource level do message references that way, rather than having a complex thing where you have matches and so forth taking place inside of statements. Is that the right solution? Maybe not. But I think it makes a lot of sense from the point of view that it makes things nice and encapsulated. And if you need to do that kind of much more advanced thing, that's sneaking up on doing string concatenation behind the scenes. You're going to get a string out of something and put it into another string. Doesn't the string that surrounds it need to interact with the contents? So maybe. But right now we're saying no, .local and .input are for annotating a value.
Yeah, and I'll just chime in there a little bit. I mean, that goes back to the example that Addison showed where you had a message nested inside a message. So, and then this right here, the slide that he was just on, shows the message format 2. So I think he's going back to the what we have currently in existing message format.
Yeah, I could do that. But
and so I think I saw it. It was there. And so then the trade-off is that sure, maybe you might have potentially a more concise message perhaps, but you're basically inviting string concatenation, which is you know, a rookie mistake. It's a no-no in localization to concatenate strings, because we don't know how different languages are going to translate things. And as Addison said, the context and the full sentence might actually change depending on how things get translated. So you never want to do that. But when you're starting to nest things, you're inviting that problem. So a conscientious decision from the beginning of our discussions in this group was, let's at least not do that. And in order to not do that, it's when you have two different selectors, you know, two different things that could potentially change at runtime or need to be translated, then you end up needing kind of the Cartesian product of all the different values that those two things can take, or however many things you have. So then it ends up looking like a long list, like in this slide. But the trade-off, the benefit of this is that the pattern that you have is the full sentence. And that's really important for translators who you know, translate these messages, that they actually have the full sentence, they have the full context. And so that's really plugging this really bad practice of plugging that hole by doing this. Yeah, so that's just sort of like how I saw that. And as Addison said, you know, there's a little bit of kind of a gray area in between where maybe you do need some like brand name that you want to insert and reuse. So, you know, the locals can help with that, but beyond that is out of scope.
I have something to add if you.
Yeah.
I think the part of the problem is that, as Alongo pointed out clearly, you don't know what's going to happen to a sentence. You don't know whether you know, the brand name Sony has to take an affix in a particular language or something like that. It leads people down garden paths that have lots of nasty things across languages. So it's much cleaner, even though it takes a lot of different sub-messages. But I think the anticipated usage in most of these cases is that there's tooling that helps the translators deal with these. And so it makes it fairly easy. I know, you know, we already have to deal with this with message format 1, having, you know, multiple messages. and you end up having the tooling sort of flesh things out for you and make things easy for you. And that's really what you want to do when you have these highly inflected languages that will get these explosions.
Mm-hmm. Great. Did that answer your question, Bert?
Yeah, I understand the reasoning. I was more thinking of reusing the same pattern multiple times rather than nesting them inside one another. But yeah, I can understand why you are hesitant to do recursion. Yeah.
Well, I'd also say that tooling can do this kind of stuff. It can notice that there are common patterns, but what you want to do is not tie the translator's hands, because you don't want to say, well, I've got this expression in there because I know it's invariant. I, the programmer, know it's invariant because it's invariant in German. But by God, it's not invariant in another language, and it needs to depend upon other things within the sentence. So you get into real trouble if you make those kinds of assumptions.
All right, thanks. And thanks for the question. Are there any other live questions? I don't see any at the moment, but we have a few questions that were submitted prior to the event. So for the people who are here right now, if you have any questions, keep them coming through the chat. And we'll go to one of, there are a couple questions that are kind of on a similar theme. So these are just kind of basic. So from Evan Torrey, what implementations are available and in what languages? And Olivier Staquet, how to implement it practically.
So yeah, so right now there's an open, there's a project available on GitHub for JavaScript. The ICU for J and ICU for C implementations will be available, knocking on wood, because they're not 100% checked in yet in the LDML45 release. So there's nothing to play with yet there. I think the for C one is pretty close to caught up at the moment. So those will be available. Practical implementation, it's we have an ABNF grammar. It's pretty straightforward. It's a long grammar, but it's fairly straightforward to parse it, and a specification that says how to consume that, and then we'll have the list of required functions. Those functions are really similar to functionality that should be in your runtime platform. So number and date formatting and string matching, those are pretty common functions to have available. So you should be able to implement this in your programming environment if you choose to make your own implementation in a fairly straightforward way. There's the test suite, as I mentioned before. It's pretty good in some areas, but it's just getting started, and so there may be some additional tests that would be helpful to you as an implementer. We're super interested in more implementations in more different runtime environments. So if your runtime environment is not JavaScript, Java, or C, we would very much like to hear from you and have you participate.
Let me add one thing, is that there are a number of shims for ICU, notably a Python shim, and various people contribute to those projects. And if you use a language that's not on the list, then you might be interested in approaching some of the people working on those kinds of projects for the language you're dealing with.
All right, thanks for the question. The next question is from Jesse Nguyen. How does it compare to ICU, and where does it fall short or perform better?
Yeah, so I think we've talked a lot about ICU's message format 1 implementation. And in terms of falling short, I can't think of anywhere where we're short of that, unless you really love choice format, because we didn't provide choice format. But at least we don't require it. You could implement it if you love it. I think it will be part of ICU going forwards, and we hope that the broad adoption applies. That people will broadly adopt this. I think it is the path out of the sort of circle that we've drawn message format 1 into. So we have a whole bunch of formatters in ICU, that we would like to see in message format patterns, because writing spaghetti code to implement that and then shoving the results into a string, that's not the answer. Implementing them in message format and making message format your primary message interface is a much cleaner way to accomplish many of the things that you want to do in terms of internationalized strings. So I think this is, as far as I'm concerned, is the path forward for message formatting.
And the other part of the question was, how does it perform better? Are there a couple of things that you want to kind of highlight? Maybe you've mentioned them already, that this is better than what we have.
I mean, initially, if you just did the built-in functions, it does all the same things, probably in about the same time. It's not more complex. I think it performs better from an authoring point of view, in that it's more, you can declare things. You don't have to retype your formatting patterns in every single place you use them. There's a bunch of things that it makes easier for you as a software developer. And then I'm also hopeful that it'll make your life easier if you're a translator as well. So I think that's sort of the key aspect, but it's not different there. It's different later because we can add the other functions to it, and they'll use the same syntax. You don't have to relearn everything.
Yeah, the extensibility, you can bring your own functions to the table. You're not stuck to just whatever ICU has said. Here's what we support. So yeah, definitely. We have one more question, live question. This is from Brian Brown. Ryan, do you want to ask your question?
Yeah, sure. Thanks. Just curious if you could elaborate more on the registry piece of it. Just trying to more of like a practical, like, is this something that's like a Docker type of registry, or like what?
Yeah, so there's more than one. There will be more than one registry. The initial thing is there will be a registry that is the list of things you must implement, the default registry, with default functions with their options and the values that those options can have and what operands those can take. Implementations are not required to package the registry or to read the registry at runtime or anything like that, but you do have to implement what the registry says and means in order to be compliant with the default. Because we'll have a machine-readable description of functions and their options, implementations can provide a way to write these things and use them, read them at plugin time. You're not required to read the registry when you plug them in. You're not required to contribute your registry to some centralized repository and get it approved. But what we would like to see is, suppose you write the list function. It would be really good if everyone, everywhere, in every platform implemented the list syntax in message format identically, because then tools everywhere would understand what a list was and how a list worked. And so we will have a process. We're just starting to work on standardizing it for people to propose, here is the function : list, and it has these options, and these options take these values. Your code to implement that is maybe your own, but everybody who has lists writes lists in the same way. And therefore, we're waggishly calling it recommended for general implementation, RGI, because that's similar to some terminology in emoji land. We may not end up calling it that just to avoid the confusion. But it's, if you write a list, here's the list of things, and you can extend that with your own options, but make your lists look like this, or make person format look like this, or make gender selection look like this. And whether that eventually becomes part of the default registry or not is a decision about what we think everyone can do reasonably versus what people can pick up and should pick up if they're implementing specific things. And then you're always welcome to extend that. Does that make sense? Does that kind of answer your question? But it's not a, like, one of the things we have are namespaces for function names. So we talked about whether we would make people register their namespace or not. And so far we're saying no. But that would be really interesting feedback if we think people are going to step on each other's toes.
Thank you.
Cool.
Thanks for the question. I think we're about at the end of our time. So let's wrap up.
I will set object permanence here. When we hang out from this, we still exist. We have our repo, and we have other places on the interweb. Please don't suffer in silence. If you were too shy to ask it today, or you have ideas later or whatever, come talk to us. We're super interested in people who want to implement, people to tell us that we're crazy. Whatever feedback we can get will be very valuable to us in ensuring that we deliver the right standard for everyone. So thank you for your support.
Yeah, absolutely. Let's see. Alrighty. So I want to thank Addison for presenting and answering our questions in the Q&A session, as well as Mark Davis. Thanks for stepping in there too. It was great to hear your insightful answers to all our questions. Thanks to Karen for all the logistics today and leading up to today to make this event possible. And finally, thanks to all of you in attendance for making this event a success. And all of us are really pleased to see the interest you've shown in message format, internationalization, and Unicode. And as Addison mentioned, this is not a done thing yet. So we're looking also for your participation and feedback as well. We plan to have the recordings from this event available in the coming weeks, and we hope you stay connected for more information, future events, and can share this information with your colleagues. For general questions regarding Unicode, please visit home.unicode.org. And to reach the message format team with any follow-up questions, open a new discussion at the repo link that Addison also shared. So you know where to find us. Have a great rest of your day. See you, everybody.